example problem number 75, found on page 96 of chapter 5, chapter on gravity. The problem reads, if Earth shrank until its diameter were only half its present size without changing its mass, what would a 1 kilogram mass weigh at its surface? So it's asking us to find G, basically the weight of a 1 kilogram mass is the force due to gravity on 1 kilogram. That's the strength of the the gravitational field. So that's the acceleration due to gravity. So they're asking us what would be the acceleration due to gravity be if RE was reduced to 1/2 RE. Okay. That's what it's asking. Fine. Given, well, that information is given that RE is now 1/2 RE. Equations, relevant equations, well, we have Newton's law of gravity. Okay, so solving, how do we do this? Well, we know that the force due to gravity, well, first of all, we know G, which is the gravitational field strength, is G times ME on Earth's surface divided by RE squared. Okay, so now they're asking us, say RE is shrunk to half. What is now the new field strength? What is the new acceleration due to gravity? So let's find that. So G, I want to call it prime. This is the new one where the radius of the Earth is shrunk to half its size. Okay. So now we can just factor out this 1/2 squared. And recognize that this is G at the surface, the strength of the gravitational field at the surface. So the strength of the field, the new field, at the planet where the radius is half of the current radius, is going to be 1. That's RE over 2, so it's 1/2 squared. So 1 over 1/2 squared is the same as 1 over 1/4, which is the same as 4. So this is 4, so it's just 4G. So, which makes sense because we're reducing the distance by a half. So if we reduce the distance by half because it's inverse square, we're going to increase the strength by 4. And so it's 4 times G, which is 39.2 meters per second squared. And so technically, that's the field strength, right? The acceleration due to gravity, gravitational field strength. They ask what is the force on 1 kilogram? Well, that's just multiply by 1 kilogram, 39.2 newtons. That's the technical answer. But because when they ask what is the force on 1 kilogram, they're basically asking what is the acceleration due to gravity, or what is the gravitational field strength. So 39.2. So if Earth's radius shrank to half of its radius, the weight of everything would increase by a factor of 4, right? Because the acceleration of gravity would increase by a factor of 4. So everything would be 4 times heavier. It's because the acceleration of gravity would be 4 times larger, the field strength.